Problem number 1, we're supposed to list two other names for angle 3. So we look for angle 3 on the graph, and that is SUT. So one of the angles is angle SUT. Also, it will work backwards, angle TUS. Problem 2, name an angle adjacent to angle 2. To do that, we need to find out where angle 2 is. It's the one with the vertex on S. So we need one that has a vertex of S and shares either the line segment ST or SU. The only one that falls in that category is angle 1, which we could also call angle AST, or the letters backwards, angle TSA. You only need to answer one of them on the test. For problem 3, we are given an angle measurement of 75 degrees, and they want to know what the measure of angle 4 and the measure of angle 5 is. Angle 4 is a linear pair. That means angle 3 plus angle 4 equals 180 degrees. So, to find the measure of angle 4, we take 180 degrees and subtract 75. That's 105 degrees. Angle 5 is a vertical angle with angle 3. That means they are the same size. So, if angle 3 is 75 degrees, that means angle 5 is 75 degrees. Problem 4 has 3 parts. First, we have to find out what x is. We know that measure of angle BDH is 3x plus 20, and the measure of angle HDF is 2x plus 10. And we know that the bigger angle, angle BDF, is perpendicular. So we know that 3x plus 20 plus 2x plus 10 equals 90, since perpendicular implies 90 degrees. Put together like terms, we get 5x plus 30 equals 90. We move the 30 over to the other side. We get 5x equals 60. Divide both sides by 5. We get x equals 12. That gives us the answer to A, what x is equal to. We then plug in for x, 12. So we get 3 times 12 plus 20 equals 56, giving us the measure of angle BDH. And we plug 12 into 2x plus 10, which gives us 34, which is the answer to the measure of angle HDF. Problem 5 is very similar to problem 4, except for instead of being perpendicular, the angles are supplementary. That means they add up to 180 degrees. So 5x plus 8 plus 7x plus 40 equals 180. Combine like terms, we get 12x plus 48 equals 180. Move the 48 over to the other side, we get 12x equals 132. Divide both sides by 12, we get x equals 11. Knowing that x equals 11, that's the answer for A. We plug in the 11 to the other two equations. We get 511 plus 8 equals 63, which is the measure of angle MOT. And we plug 11 into 7x plus 40, and we get 117 degrees. A quick check for this problem and the last. If we add up the two angles for BC, in problem 4 we should get 90, and problem 5 we should get 180. We need to find the distances between the 3 points of the triangle. -5, 0 to 0, 6. We need to know what the A and B are. Well, -5 to 0 is 5, and from 0 to 6 is 6, so we get 5 squared plus 6 squared, which is equal to 25 plus 36, which is 61. So the square root of 61 is 7.81. Next, we need to find the distance from 06 to 30, which would be 6 and 3. So 6 squared plus 3 squared is equal to 36 plus 9, which is 45. Or the square root of 45 equals 6.71. From -5, 0 to 3, 0, it's -5 to 0 is 5, and from 0 to 3 is 3, so it is 8 apart. So to find the perimeter around the triangle, we're going to take that 8 plus the 7.81 plus the 6.71 to get 22.52. The perimeter says to the nearest tenth, so we cut it off at 22.5 units. For the area of a triangle, it's 1/2 base times height. That's 1/2 times 8, which is the distance across the bottom of the triangle, and the height is 6 because from the point 0, 0 up to 0, 6 is 6. 1/2 times 8 times 6 is equal to 24. For section 2.4, we're going to problem 8, revisited and corrected from the last version. So what we're going to do is we're going to start with reflected over the y-axis. To do the y-axis, we're going to take the x value and make it negative. So it's going to be negative x, y. That means 2,4 becomes negative 2,4, negative 5, 6 becomes 5, 6, and 3, negative 1 becomes negative 3, negative 1. For B, we're going to do a rotation of 90 degrees counterclockwise, unlike what I did on the previous video, which I did 90 degrees clockwise. To do that, it's going to be negative y comma positive x. So we're going to switch the x's and y's, and we're going to make the y negative, which is how we get negative 4, 2, negative 6 comma negative 5, and positive 1, 3. For the translation one, we're going to take all the x's and we're going to add negative 3, and for all the y's, we're going to add 4, which is how we get the negative 1, 8, the negative 8, 10, and the 0, 3. For problem 9, we need to find the surface area of a cylinder. So we look at our notes and we find that it says 2 pi r squared plus 2 pi r h. R in this case is 10, h in this case is 41. Plug those numbers in, we get 2 pi 10 squared plus 2 pi 10 times 41, which is 200 pi plus 820 pi, which is 1020 pi centimeters squared. You'll need to put the centimeters squared in your answer. However, if you plug them in and use 3.14 for pi, you'll get about 3,202.8 centimeters squared. There's a little latitude there with rounding. For problem 10, we have a triangular prism, so we need to find the area of the base, which is the area of the triangle, which is 3 times 4 divided by 2. And we're going to multiply that by the height of the prism, which is 8. Multiply that out, we get 48. Since it's volume, that is centimeters cubed. For section 2.6, we're going to take the 3D shape and turn it back into a front, right, and top view. When we're looking at the front, we're looking at the black squares. That gives us a 3 across, 1 up black square with 1 square sticking out at the top and another square sticking out to the right. For the right view, I see a backwards L shape of 3 squares, 2 with 1 on top. Then, jutting out of both of those are 2 squares underneath it. So there are squiggly lines between the top 3 and the bottom 2, and a squiggly line between the bottom 2. For the top 2, I gave 2 very similar answers. So what I have for the top view, I'm going to start from the top and work my way down. I'm going to put a square for the tallest point. The next tallest point is next to it to the left. Then below that are 3 points that form that reverse looking L shape. And then to the very top of the drawing, there is 1 square that we can see. Now it does say show only the blocks that you see exist, but I will accept the fact that you could possibly believe that there is a base there and there's a square next to it, which is the TO2, which was supposed to say top 2, but apparently I misspelled top. Section 2.8 is significant digits. So for 12a, we're looking for the number of significant digits. The 3 is significant, the 1 is significant, the 7 is significant. The only reason the 2 zeros after the 7 is significant is because it's on the other end of the decimal point, which means there had to be a reason for us to write them down. So 5 significant digits. For 12b, we're looking at the 3 being significant, the 1 being significant, the 7 being significant, but the 2 zeros are only there to be placeholders. So 3 significant digits. For C, even though there are 2 zeros there and a decimal point, the decimal point and the zeros are just pushing where the 317 is. So again, only 3 significant digits. You may be wondering why problem 13 looks different than problem 12 or all the others for a fact. Well, The story is, as I was recording the video, I noticed that instead of finding perimeter, I found area, which is a slight problem. So the perimeter is the measurements of all the sides around, which would be 10 inches plus 12.1 inches plus the 10 inches on the other side and the 12.1 on the other side of that other side, which adds up to 44.2. But we're supposed to be using significant digits. 10 inches only has one significant digit, while 12.1 has three significant digits. The lower number is 1. That means we can only use one significant digit, which is why the answer is 40 inches. For this test, remember to take your time, to look at your notes, to use your notes effectively, and work on the problems you know how to do, and then go back to the ones that you don't know how to do. Time is important. You want to use all the time in class for the test. You will not get extra time. Thank you.